SpaceX's Starship program has taken us into a new era of space exploration, pushing the boundaries of what reusable rockets can accomplish. As we gear up for the sixth flight, scheduled for November 18th, anticipation is building around the next steps for this ambitious project. This test will take place at SpaceX's Starbase in Texas, where a 30-minute launch window will open at 5 p.m. Eastern Standard Time, allowing for another landmark moment in space technology if all goes as planned. Since its first flight, the Starship megarocket has continued to evolve, with every mission building on the successes and learning from the challenges of its predecessors. In this sixth test, SpaceX aims to surpass its last notable achievement, a controlled return and capture of the massive Super Heavy booster using the launch tower's unique chopstick arms. Each mission has progressively refined Starship's technology, enhancing its capabilities and moving closer to full reusability, a critical feature for making human life multiplanetary. Starship's ultimate purpose goes beyond Earth's orbit, promising to revolutionize space travel and open doors for interplanetary missions, including Mars colonization. This November 18th flight marks a significant step in SpaceX's journey to realize that vision. So join us on this journey, subscribe and stay tuned as we continue exploring the future of space exploration with SpaceX's Starship. Starship represents the pinnacle of rocket engineering, a towering 400-foot behemoth designed not only for power but for full reusability, an ambitious goal that sets it apart from every other launch system to date. At its core, Starship is composed of two main parts, the Super Heavy booster and the upper stage, simply known as Starship. Together, they form a dynamic duo capable of delivering unprecedented payloads far beyond Earth's orbit and, one day, supporting human life on other planets. The Super Heavy booster, which forms the base of the rocket, is a powerhouse equipped with 33 of SpaceX's cutting-edge Raptor engines. These engines burn a mix of liquid methane and oxygen, a combination chosen for its efficiency and its potential for future refueling on Mars, where resources might be limited but methane could theoretically be synthesized. With the booster's powerful thrust, it propels the upper stage, Starship, through Earth's atmosphere and into the vacuum of space. This upper stage, standing at 165 feet tall, is fitted with 6 more Raptor engines and is designed to carry not only cargo but, in the future, humans as well. What truly makes Starship revolutionary is its reusability. The booster, after delivering Starship on its trajectory, returns to Earth for a controlled descent. Unlike conventional rockets that are discarded after use, Super Heavy aims to land near or even directly on its launch pad, ready to be used again with minimal downtime. On the upper stage, Starship itself is equipped with heat-resistant tiles that protect it during the intense reentry process. With each flight, SpaceX is refining these systems, from heat shield durability to controlled booster captures, inching closer to a fully reusable system that can cut the costs and timelines of space travel. The Raptor engines powering Starship are no less impressive. They represent a generational leap in rocket propulsion, with enhanced thrust, efficiency, and adaptability. These engines not only support the complex maneuvers required for launch and landing but are key to Starship's future role in deep space missions. The fact that they are designed with reusability in mind, able to withstand multiple launches and re-entries, underscores SpaceX's vision of transforming space travel from a single-use endeavor into a sustainable enterprise. With this next test, SpaceX isn't just sending a rocket into the sky, they're pushing the very limits of engineering. Every part of Starship, from its engines to its heat shields, is meticulously crafted to withstand the punishing conditions of space and to be ready to do it all over again. Each flight teaches valuable lessons, and this upcoming launch is yet another step in refining Starship's components for the future of interplanetary exploration. This upcoming Starship flight, known as Flight 6, is a pivotal test, with objectives that could further transform the trajectory of reusable rocketry. This mission isn't merely about reaching orbit, it's designed to push the boundaries of what Starship can achieve, testing the hardware, software, and engineering principles that will one day support sustained missions to the Moon, Mars, and beyond. Central to this test are three major objectives: another controlled catch of the Super Heavy booster, an in-space reignition of a Raptor engine on Starship, and critical re-entry and descent trials for the upper stage over the Indian Ocean. The booster catch, which involves a complex descent and capture using the launch tower's unique chopstick arms, is a feat of engineering. It eliminates the need for traditional landing pads and minimizes turnaround time, taking SpaceX closer to its goal of rapid reusability. The last mission proved it could be done, but this test aims to refine the precision, allowing Super Heavy to land safely and swiftly, potentially reducing the need for extensive post-flight inspections. Each catch brings the system closer to operational reliability, where rockets could theoretically launch and land in near seamless succession. Another core aspect of this mission is the in-space reignition of one of Starship's Raptor engines, a vital capability for future missions that will rely on multiple engine burns to reach distant destinations or enter stable orbits around other planets. Reignition capability allows for course adjustments, orbital insertion, and even controlled descents, which are essential for complex interplanetary missions. Testing this function in space will validate its readiness for the diverse demands of deep space exploration. Perhaps one of the most ambitious elements of Flight 6 is the upper stage's re-entry and descent trial. Unlike conventional re-entry profiles, Starship's unique design requires it to enter the atmosphere at extreme velocities while maintaining stability and controlling heat buildup. This flight will test Starship's heat shield, maneuvering flaps, and descent algorithms, gathering data on how the vehicle behaves in the brutal re-entry environment. It's a balancing act. Starship must withstand searing temperatures and intense pressure, all while maintaining control for a potential precision landing in the future. SpaceX has designed this test to expand Starship's reusability envelope further, pushing it closer to a fully operational, reusable spacecraft capable of routine missions. Each success brings SpaceX a step closer to reducing the cost of space travel and enhancing mission flexibility, goals that could reshape humanity's relationship with space. Flight 6 of SpaceX's Starship program isn't just another test, it's a demonstration of the iterative advancements that are gradually perfecting this revolutionary system. For this mission, SpaceX has implemented several targeted upgrades to make the rocket more robust, efficient, and responsive to the demands of reusable spaceflight. These refinements cover everything from structural enhancements to software improvements, each designed to bring Starship closer to achieving fully reusable, cost-effective space travel. One key upgrade focuses on the booster's propulsion system. SpaceX engineers have added redundancy to the booster's propulsion, allowing it to handle potential failures without compromising the mission. This additional redundancy is crucial, as it means the booster can sustain a higher level of reliability, even if some components experience issues. In a rocket with 33 engines on the Super Heavy booster, this kind of backup system ensures a safer return journey, even during high-stress maneuvers such as controlled descent and capture by the launch tower's chopstick arms. This system improvement is vital for boosting mission success rates and minimizing risks associated with the booster's ambitious reusability design. Structural upgrades are another major focus for this flight. SpaceX has reinforced key areas of the booster in the Starship upper stage, increasing the vehicle's strength to withstand the stresses of launch, re-entry, and capture. These reinforcements are designed to support the hardware as it undergoes repeated use, enabling each component to endure multiple missions without requiring extensive refurbishment. This durability is essential for Starship's goal of rapid turnaround times, allowing for faster relaunches and ultimately lowering the cost per mission. In addition to physical upgrades, SpaceX has enhanced the Starship's onboard software and control systems. This updated software includes refined algorithms that control the booster's descent, re-entry maneuvers, and the complex timing required to achieve precise landings. These algorithms have been improved based on data from previous flights, making the Starship system more responsive and adaptable. Software control is especially critical for a reusable system where each second counts. With tighter controls, the Starship and booster can make fine-tuned adjustments in real time, optimizing each phase of the mission. SpaceX has also redefined the commit criteria for this launch, which means that mission controllers now have updated guidelines for go/no-go decisions based on real-time data. These criteria are set to prioritize safety and mission success, taking into account the new upgrades and performance data gathered from previous flights. This approach underscores SpaceX's commitment to data-driven adjustments, continually refining its process to make Starship as dependable as possible. Finally, another practical improvement involves shortening the time needed to offload propellants from the booster after a successful catch. This is a small but meaningful change, as it allows ground teams to work more efficiently and brings SpaceX closer to its vision of rapid rocket reuse. By reducing turnaround time, SpaceX is setting the stage for a future where rockets could theoretically be launched, caught, and prepped for another mission in record time. With each incremental enhancement, SpaceX is moving Starship closer to becoming the workhorse of interplanetary missions. These hardware, software, and structural upgrades signal a focused and determined approach to developing a rocket that can withstand the rigors of space travel time and time again. The upcoming Starship test is more than just a step forward, it's a glimpse into the future of space exploration. SpaceX envisions a world where space travel is no longer a one-time endeavor but a regular, sustainable journey, unlocking the potential for Mars colonization, lunar bases, and interplanetary missions. With each launch, Starship moves closer to transforming this vision into reality, redefining humanity's relationship with the cosmos. This mission aims to validate the core capabilities that will enable Starship to venture beyond Earth repeatedly, reliably, and cost-effectively. By perfecting rapid reuse, minimizing refurbishment, and enhancing every aspect of Starship's performance, SpaceX is creating a path toward a new era of exploration, one where the barriers between planets start to fade. Imagine a future where humanity has the technology to not only reach other worlds but to establish a presence, extending the boundaries of our civilization into the stars. As we anticipate this landmark launch on November 18th, we're reminded that each milestone achieved isn't just about reaching new heights, it's about building a foundation for the generations that will follow. If Starship succeeds, it could pave the way for humanity to become a multi-planetary species, turning science fiction into achievable milestones. Stay tuned as we watch history unfold, and be part of the journey by following SpaceX's progress. We're on the brink of something extraordinary, and every launch brings us closer to an era where the stars are within reach.